Hey you guys, another air puzzle review. I'm working off of unit 2B, packet, I think this is packet 2B, and it's going to be over creating equations, well, graphing equations. So, we pulled a couple of the questions from the beginning of the packet and made the air puzzle review, so that's why the numbers are missing at the top, but you'll see them on page 4, I think it's page 4 of your packet. So I guess we'll go ahead and get started with the first one, which is going to be example 2. They want us to find the slope from the equation, but let's go ahead and refresh our memory of what slope interform is. It's really big. And we can also refresh what these different parts mean. So I know y is going to be my dependent variable. Yeah, this is really big. I'm going to have to erase this to be able to do the problem. This is going to be the B is going to be the y-intercept. I'm sorry, y'all. I'm not sure why I jumped around like that. That's not spelled right. M is going to be the rate. And X is going to be our independent variable. I'm going to actually make this one red too. Just so they're kind of color coded. Because we know the independent variable and the dependent variable X and Y go together. And you'll normally see the y-intercept and slope commonly referred to in like the same questions. So that's why I colored them that way. So we know that if our equation is in slope-intercept form, all we have to do is identify what the M is. And from this setup here, we see M is just going to be the coefficient in front of the X. So if we have Y, a single 1Y equal to mx plus b, all we have to do is find a coefficient in front of the x, and that'll tell us what our slope is. So let's take a look. I'm going to just copy this. Actually, I'm going to delete it now. So my equation is y equals negative 2/3 x minus 1. Let me verify that this is going to be in slope-intercept form, because I know once it's in slope-intercept form, all I have to do is identify the coefficient in front of the x term. So yes, this does look like the format we just learned, or we just looked at. Y equals mx plus b. And in this case, we see the m is going to be negative 2/3, because that is going to be the coefficient in front of the x term. So here, slope, we can write that as negative 2/3. Let's take a look at the next example. Oh wait, going to go there here. So we have 2x plus 5y equals 10. Now, we know how to do it real easy when it's in slope-intercept form, but in standard form, there's not really a way to quickly identify what the slope is. But what we can do is put this standard form equation into slope-intercept form. So that's what we're going to do. So we know for slope-intercept form, it has to be y is equal to something. Y is equal to mx plus b. That's the general format. So what I'm going to do is I'm going to solve for y, because that's essentially what this is. It tells us what the value of y is. So I want to get what y is by itself. So I have 2x plus 5y equals 10. I'm going to subtract 2x from both sides because I'm trying to isolate y to get it by itself. 2x minus 2x is going to be 0 because they're additive inverses. So I have 0 plus 5y equals 10 minus 2x. Now at this stage, I see that y is being multiplied by 5. So I'm going to do the inverse operation of that because I want to get y by itself. Because we see that's what we have up here, y by itself. So I'm going to divide both sides of well, each term by 5. So that leaves me with y is equal to 2 minus 2/5 x. And to make it just look like this format, I could just rewrite it to say y equals negative 2/5 x. That does not look like negative 2/5 x. Plus 2. So now this format looks like what we're familiar with. And from here, all we have to do is look to see what is in front of our coefficient. I mean, what coefficient is in front of our x variable. That's what I mean. So I see x is here. And I see the coefficient in front of that is going to be negative 2/5. So notice how I'm including the negative sign. So I want to take the entire coefficient. So that's inclusive of the sign. So I need to know if it's positive or negative, because again, that determines the direction my graph is going to go. It's either going to go up for positive or down for negative. So that negative 2/5 is very important, and that's a completely different answer from just 2/5. So here we could write as our final answer, the slope is negative 2/5. So let's look at these examples over here. So they want us to find the slopes given 2 points, and that's good because we have a strategy for that. We know we take y2 minus y1 over x2 minus x1, and that's actually just rise over run, which I think we're all familiar with or have seen at some point. Rise over run. And I'm gonna just write it one more way. And you guys can tell me which way do you remember it. Some people say the change in y over the change in x. So, but for this problem, we're gonna stick with this way. y2 minus y1 over x2 minus x1, because that's just going to make it really easy for us to plug in. But note that these are all equivalent expressions. So I'm actually going to label this term, well, point 1. These are points. This is going to be point 1. This is going to be point 2. Move this down so I could label. I know this is the x coordinate. This is the y coordinate, this is the x coordinate, this is the y coordinate. And that's going to be consistent. It's always going to be written x, y, regardless. That's going to be the general format for a point. So when I label it 1 and 2, x and y on each different point, that helps me figure out what y2 is. So I know I have to look at the second. Ooh, I didn't know it was going to be that big. I have to look at the second point, so that's going to be here. Then I have to look at the y term, so that's going to be 7. So I'm going to plug that in, and then I'm going to look at the first term, which is going to be this one, and I'm going to look at the y, that's going to be 5. So now I have 7 minus 5, and I'm going to do the same thing for x2. I'm going to look at the second point, x term. I see that's negative 2. Now make sure that we put in that negative sign, because we know that can completely change our answer. And then I'm going to have the x1 term to be 0, because I see that is the x term in the first point. So now I'm just going to simplify this, because this is going to be equal to the slope. This is going to tell me how fast my graph is changing. So 7 minus 5 is going to be 2. Negative 2 minus 0 is just going to be negative 2. A positive 2 divided by negative 2 is going to give me a negative 1. So not only do I know how fast things are changing, I know what direction. And do you guys mind? I'm going to not pause it, but I'll add a question here. What direction is this graph going in example 2? So your choices will be up or down. So let's take a look at number 4. So we're going to do the same thing. I'm first going to just label 1.1, 0.2. Then I'm going to label this x, and I'm going to label this y. I'm going to label that one x, and I'm going to label this y, because I know the general format for a point is going to be x, y. And then I'm just going to refresh my memory with what the slope formula is. It's going to be y2 minus y1 over x2 minus x1. So when I'm tasked with finding the slope from 2 points, this is what I would do for my general setup. This is what I would do regardless. I would first label my 2 points, 1 and 2, and then I would label inside of each of those X, Y. And then I would write out what the formula is, because from there I could literally just plug in. So that's what we're going to do now. So I see Y2 is going to be 3. I see Y1 is going to be -3. I just go to 0.1. And then I look at the Y term, that's going to be a -3. And then for X2, I see that's going to be 1. And then for X1, that's going to be a -2. So make sure that you're also keeping up with your signs. So parentheses can help you do that so you don't lose anything. 3 minus a -3, that's going to turn into 3 plus 3. 1 minus a -2 is going to turn into 1 plus 2. So I have 6 over 3, because 3 plus 3 is 6, and 1 plus 2 is 3. When I simplify that, I get 2. So my slope here is going to be 2. And note, when we have a constant, it's just assume we're writing 2 over 1. So we're saying that we're going to rise up 2 blocks for every 1 we run over. But when we get to the bottom, we'll talk more about that. Let's see what the next question is. Okay, so they want us to find the slope from the table. So what we just did was we said Y2 minus Y1 over X2 minus X1 would give us our slope. That's what we said. And they gave us the points side by side. They said this, that. So when we have a table, they're giving us the points. We have 1 right here. We have 1 right here. These are all different points. Up here, we only had 2 to choose from. It was simple. But here, we kind of have freedom to choose our own points. But I'm going to tell you guys, I would stick with the points that are positive. They have positive on both sides. Or where the Y2 value is higher than the next value. But if you have a negative slope, you may not be able to do that. But I'm just going to avoid working with these up here, because I think the 1 and 2 down here would be easier. And I'm going to just try and explain that a little bit better. So I'm looking at this formula here, and I'm going to try and plug in. That's the formula I'm looking at. So I see the second point, the Y coordinate is going to be 9. Put this in a different color so you guys can know I'm plugging in. And then the Y coordinate of the first term is going to be 0. And we can do the same thing for the bottom. The X term for the second one is going to be 2. And for the first one, it's going to be 1. So we have 9 minus 0 and 2 minus 1. So I have 9 at the top, and then I have a 1 at the bottom. That simplifies to just be 9. So for this one, I'm going to write the slope is 9. So I guess what a good tip would be, I'm just trying to choose friendlier numbers. So I was just trying to stick with the numbers that were all positive. That was the suggestion I had. But sometimes you will be handed a table that doesn't have any positive terms in it. So in that case, of course, you will have to just choose the negative ones. Okay, let's take a look at... Okay, so now we're moving into finding the y-intercepts. So let's talk about the context of that before we jump into it. I'm just going to go over here. This is going to be my y-axis. This is going to be my x-axis. Y-intercept. If we think about it, an interception is like when someone... Well, in football, I think it's when the ball gets the other team takes it. But for our case, it's when it crosses over. So when it crosses this, I'm going to highlight it orange, this line, it's a y-intercept, okay? And if it's going to be on this line, the first term has to be 0. So it's going to be 0 comma something anywhere on this line. That's what your term will look like, your y-intercept will look like regardless. 0 comma something. And this is going to be for all y-intercepts, okay? So if you guys don't take anything from this video, know that your y-intercept must be in the form 0 comma x, because the first term in our coordinate, the x coordinate, is telling us how far we're moving on the x-axis. It's telling us if we're moving this way or if we're moving that way. But if we're directly laying on this y-axis right here, this orange y-axis, we're not going to the right at all, or we're not going to the left. So we're going to be laying right in the middle. So that's going to be a 0. That's why we get the 0. And this x here, there's just to represent a random number, because it could be any number. It could be 0 comma a million. There are no restrictions. That's not how I write a million. 6 zeros. Okay, so let's go back down. So they want us to find the y-intercept from the equation. So let's think. We know we have this form we just talked about up there. Is it still in my copy and paste? Yeah, cool. Okay, so this was the form we were just looking at. And we said to find the rate or the slope, same thing. We just had to look at the coefficient in front of the x term. But to do our y-intercept, we need to look at the constant. That's what we're going to look at. And we know what constants look like, because you guys knocked that out the park in Unit 1. So constants look like they don't have a variable with them. They're just the regular numbers that we're used to. So I'm going to hold this up here just for a little minute so we could look down at example 2. So if we compare these two formats, I see the b in example 2 is -1. Right? That's the constant, -1. But we have to write it as an ordered pair. But if we just discuss what the format is going to look like regardless, I know it's 0 and then my b, right? So if b is -1, I could substitute -1 wherever I see b. So this would make my y-intercept 0 comma -1. That's fairly easy, right, you guys? But note, again, it's only this easy when it's already in slope-intercept form. I should have made that distinction in the beginning. So here we have, like up there, we have y equals mx plus b. It's not 5y, it's not 6y, not 7y, not 1/2 y, it's 1y. So in order to do this and look for the constant, we have to have 1y. If not, we'll have to solve, and that's what we're going to do for the next example. So we have 2x plus 5y equals 10. So we can't just look at the constant and say that this is our y-intercept, because that doesn't work here, because this is in standard form. This is in ax plus by equals c form. And we know c does not represent the y-intercept. C represents like the total. So no, we have to convert this to y-intercept form. So we need to solve for y. What is a single y equal to? So I have 2x plus 5y is equal to 10. I'm going to move the 2x over. 5y is equal to 10 minus 2x. Maybe I should write that I subtracted it from this side. They're additive inverses, so they cancel out. Then I'm going to subtract 2x over here. And now I'm going to divide by 5 again, like I did on the example above, because I see 5 is being multiplied by y. And I want to get y by itself. So I need to undo that multiplication by division. So I have y equals 10 over 5 minus 2/5 x. This is going to simplify to y equals 2 minus 2/5 x. And if I put this into my format from above, I could just switch out the order. Y equals negative 2/5 x plus 2. Now I need to identify what is the b. And here the constant, because b is equal to the constant. I know the constant here is going to be plus 2. So I know my y-intercept is going to be 0, b. So that would just be 0, 2. So that's going to be my y-intercept for question number 2. So I think there's 2 more examples. So they want us to find the y-intercept from the table. So this is kind of just, they're trying to just check to make sure you guys really know what we're discussing. So up here, we just said that to be a y-intercept, your x term has to be 0. The x term has to be 0. Has to be 0. That's how we know it's the y-intercept, because it's laying on our y-axis. If the x is 0, that means it's not going to the left or not going to the right. So in example 3, we need to find where in our table is the x value equal to 0, because that's going to be our y-intercept. So is it here? No. Looks like it's the next one. The x term is 0. That's the check. And the y is -9. I mean, that's fine with us. We don't have any restrictions for what the y has to be. But I know x has to be on that y. X has to be 0. So on the y-axis. So this passes our check. So I could just show you guys why the next ones don't work. This one isn't 0. This isn't 0. So that doesn't work. And 2 is not equal to 0. So that doesn't work. So for this one, it's going to be really simple. We'll just write out 0, -9. So I'm just writing what the y value is, because that's how I write a coordinate point. I write x, y. So hopefully that wasn't too bad. So for example 4, my method in number 3 was to look for where there is a 0 in the x. But I don't see a 0 up here. This one doesn't work. This one doesn't work. This one doesn't work. And I'm assuming this is supposed to be a 4. I'm sorry about that. And this one does not work either. So what I need to do is figure out what was the value at 0. Now, I'm not sure if you guys noticed, but there seems to be a trend. This seems to be a difference of 3. This seems to be a difference of 3. This seems to be a difference of 3. This is a difference of 1. This is a difference of 1. This is a difference of 1. 3 over 1 equals 3. This is our slope, because we know this is just rise over run. So this is another way we could have did it from the table up above. So I'm going to ask add a question there. Do you guys are you familiar with this method? So y represents the change, vertical change. This is the horizontal change. So this really represents rise over run. So if there is, I wish I shouldn't have wrote that right there so I could show y'all this table. Okay, hopefully y'all made a mental note that x is for horizontal change, y is the vertical change. So up here I see there's an increments in 1. So I'm going to do another increment of 1. And here I see there's an increment of 3. So now I'm going to subtract 3. And I'm going to subtract 1 from 1. So that's going to give me 0. All I'm doing in that step right there was I was just following the trend of the data. I'm going to change it to another color so y'all could tell that was an addition. So in purple, I noticed the trend, but I continued it on the left of my table. And I noticed also I did the work and I saw the slope was 3. So I could just subtract 3 here to get what the previous point was. And that previous point just so happens to be 0, 30. Because I know the x value is 0 and the y value is 30 according to the table. And I know when I have 0, something, that's the signal to me that it's my y-intercept. So that's all the work that we need for example 4. So I do think those are all of the questions for the Edpuzzle. As always, let me know if you guys have any questions or if something was unclear. Take care, wear your mask, be safe.